Okay, so let's try and find the equation of the graph. So we're always going to start off with a y equals over. We're working with fractions, we're just going to set that up. And we know that we have a general form of a over x minus h plus k, where k contributes to the horizontal asymptote and h contributes to the vertical asymptote. So y equals over. So we have a vertical asymptote at x equals 2. So I can simply take x equals 2 and I can subtract 2 from both sides. Therefore, this goes on the bottom. Now we have a horizontal asymptote at y equals 0, so we simply just put a plus 0 off to the right, which is unnecessary. Now we're going to put a on the top. So now we have the point 3, 1 for x and y, and we're simply going to put those points in for x and y. So y is 1, x is 3, and we get a over 1. If we times both sides by 1, we get a equals 1, and then we can rewrite it. Y equals 1 over x minus 2. Finding the equation. Now, if you are familiar, as we are, with our original graph 1 over x, it should be very easy for us to see, well, it was just moved to the right 2, which is just a horizontal translation to the right 2. Okay, let's come up with another equation. So if you remember the theory from the last time, y is equal to over a x minus h plus k. So we have our horizontal asymptote of x equals 0, so we can simply put x on the bottom. Vertical asymptote. We have a horizontal asymptote at -1, so we can put that off to the right, because we want to remember h contributes to the vertical asymptote and k contributes to the horizontal asymptote. So now we have an a value. So now we have the point 1, 0 for x and for y. So I can substitute those in. So y is 0, so 0 equals a over the x value is 1 minus 1. If I add 1 to both sides, and I cross off the 1 from below, a is equal to 1. So I can rewrite it, y equals 1 over x minus 1. And we should be very familiar that it's just a graph 1 over x shifted down 1. So that's one form. We also have another form. The other form is y equals a, and thinking about our x-intercepts on the bottom of the fraction, over the vertical asymptote again, as we've seen before. So y equals a, now I have an x-intercept at 1. So the factor is x minus 1. One more time. I have an x-intercept at 1. So the factor is x minus 1. And my vertical asymptote is at 0, so I can put x on the bottom all by itself. So now we have to talk about our horizontal asymptote. And our horizontal asymptote is at y equals -1. And if we remember horizontal asymptotes, we have case 1, the exponent of x is higher on the top. We have case 2, the exponent of x is higher on the bottom. And we have case 3, where the exponent of x is the same on the top and the bottom. So here we have x to the 1 and x to the 1. So the exponent of x is the same on the top and the bottom, leading us to believe that our horizontal asymptote would be y equals the fraction of the coefficients, 1 and 1, 1 and 1. We need it to be negative. So all we're going to do is do a nice little trick and call a -1. So when we distribute that negative, we get y equals negative x minus 1 over, plus 1 over x. And we have the same exponent of x on the top and the bottom. Therefore, we have a horizontal asymptote at y equals the coefficients 1 over 1. So this equation is exactly the same as this equation. Feel free to graph both in different forms. Feel free to graph both with a table of values or on your graphing calculator and make sure that they're the same. So again, we're going to consider both forms. If we want to do it by putting the horizontal asymptote off to the right, sure. If we want to do the form with the x-intercepts, we're going to put the x-intercepts on the top. Be careful. It's never perfect science. We're always going to either try one or like the other, depending on the equation, depending on what the graph looks like, depending on what we're thinking at that moment in time. So just to review, we have y equals a over the vertical asymptote plus the horizontal asymptote as one of our forms. And we have y equals the vertical asymptote still on the bottom, but we're going to put the x-intercepts on the top, and then we're going to choose an a value that contributes to our horizontal asymptote. Okay, let's find the equation of this one. Kind of looks like 1 over x. Let's just start off with our simple form, y equals over. So I'm not going to write the general form down every time. You've got it in your notes, so let's substitute. So we have a vertical asymptote at x equals 0, so we're going to place an x on the bottom. We have a horizontal asymptote at y equals 0, so we're going to put a plus 0 off to the right. Doesn't matter. Now, we've got our a on top. We have to solve for our a. It's not always going to be a nice simple value like 1 or negative 1. So let's take the point that we have. I always write down the point. 1, 3. I always put x comma y above or below the point because it's so confusing and sometimes we'll make those silly mistakes. So we can put 3 in for y and we can put 1 in for x. We can times both sides by 1, so a equals 3. And we can rewrite the equation y equals 3 over x. These simple ones are only going to have one form. All right, let's take a look at this one. So we have our regular y equals over. We have our x-intercept, our vertical asymptote at x equals 0, so we can place x on the bottom. We have our horizontal asymptote at y equals 0. We can place a plus 0 off to the right. Now we have our a on the top that we need to solve for. So we have our point, 1 comma negative 2, x and y. So I can take that and I can put it in for x and y. So y is negative 2 equals a over our x value of 1. We can times both sides by 1, and a equals negative 2. And we can rewrite it. Y equals negative 2 over x. Notice it's our graph of 1 over x Now, if we have a negative in front, that's a vertical reflection, and if we have a 2 on the top, that's a vertical expansion. So that's a vertical reflection and a vertical expansion equaling 2. Again, this one's only going to have one simple form. Okay, let's take a look at this one. So y equals over. So I have my vertical asymptote at x equals negative 2. So what goes on the bottom? Well, remember it's the opposite. So x plus 2. Because if I set that equal to 0 and solved, I would get negative 2. Now I have my horizontal asymptote off to the right. And I'm going to put that negative 1 off to the right. And I'm going to place my a on the top. Now they've given us a point. So negative 1 comma 0, x comma y. So I can replace 0 in for y, negative 1 in for x, and I can solve. I can add 1 to both sides, I can simplify the denominator, and I simply get a equals 1. Therefore, y equals 1 over x plus 2 minus 1. Now notice, this one has an x-intercept. So let's try the other form. So y equals over. So we always put our vertical asymptotes on the denominator. Now this time, we are going to put our x-intercept on the top. Remember, we put the factor. So if the x-intercept is negative 1, we have to put x plus 1. Keep in mind, I've made a mistake on the denominator. The denominator should say x plus 2. Now we have the a in front. So we need to find the horizontal asymptote again. Keep in mind, we have the same exponent of x on the top and the bottom. We need a horizontal asymptote to be at negative 1, and we're going to do the same trick that we did last time. Y equals negative 1, where we just simply say a is negative 1 in order for, if we were to distribute, we would get y equals negative x plus 1, negative x minus 1 over x plus 2, which means that our horizontal asymptote is at y equals the coefficients, negative 1 over 1, which is negative 1. So really using intuition to figure out what your a value is. These questions aren't going to be too complicated. Knowing all of these different things to do at different times or using different formulas is complicated enough. So usually the a value will be rather simple. Outside of that, graph it on a graphing calculator and make sure that it's the same as the original. And be very comfortable using both forms. And as you can see in your notes, we've added and subtracted fractions with the lowest common denominator to make sure that this equation is exactly the same as that equation. Keep in mind, you could also do long division. Okay, let's find the equation of this one. So y equals over. Now I have two vertical asymptotes. So I have this vertical asymptote and I have this vertical asymptote. So all I do is I put the vertical asymptotes on the denominator. Remember, it's the opposite. So now my horizontal asymptote is y equals 0. So I can just simply put a plus 0 over here. I can put my a on top, and I will let you either look through the notes or practice on your own. But if you see in the notes a is equal to 1, so we can simply write it, y equals 1 over x plus 2, x minus 2. And that is the equation. Notice in the notes I've called it 1 over x squared minus 4 if I simply FOILed out the denominator. And that form is fine. We could work on other forms each time. Feel free to practice them on your own. This graph doesn't have any x-intercepts, so I don't want to use the other form. Okay, so now let's see a similar question like the last one. So y equals over. So we have two vertical asymptotes again. So remember, we put the vertical asymptotes on the denominator. So x equals negative 3 means x plus 3. And x equals 1 means x minus 1. Our horizontal asymptote is y equals 0, so we can simply put a plus 0 over here. Then again, now we have an x-intercept. So we want to put the factor of the x-intercept on the top. So x plus 1, given our x-intercept is at negative 1. Now, keep in mind, if I put x-intercepts on the top, I cannot use my horizontal asymptote method, whereby I need to put the a in front, which is going to contribute to that asymptote. So now I can pick a point. In the notes, as you can see, we've substituted the point 2 comma 3 over 5, solve for a, get our a value, and rewrite it. Y equals x plus 1 over x plus 3, x minus 1, giving an a value of 1 unnecessarily. Now, I'm just going to quickly circle the answer and FOIL out the top. So, y equals x, and FOIL at the bottom, x squared, which means I have a exponent of 1 on the bottom, on the top, and 2 on the bottom, and 2 is greater than 1. Therefore, it's higher on the bottom. Therefore, my horizontal asymptote is at y equals 0. So all sorts of ways to work through these. You may want to use one form, you may want to use the other. Both with benefits. Okay, let's take a look at a graph with a hole. So again, y equals over. We don't have any vertical asymptotes, so nothing goes on the bottom at the moment. Now we have a hole at -2, comma -1, which means that if we have a hole at x equals -2, that means that the factor is x plus 2 equals 0, and we need to put that on the top and on the bottom. It will be crossed off eventually if we were to solve for things. However, the function needs it. So if we have a hole, we simply put the hole on the top and the bottom. Now we don't have any other vertical asymptotes, but we do have an x-intercept at -1. So we're simply going to put x minus 1 on the top. Remembering, we put our x-intercepts on the top. And now I'm just going to partially multiply it out again like I did last time. So x, we're going to have x squared over x. So that's x to the 1 on the bottom, which means we have a higher degree on the top. 2 is greater than 1, which means we do not have a horizontal asymptote. So now I can simply put a in front. Then I'm going to take this equation down below. So we have y equals a open bracket x minus 1 over x plus 2 and x plus 2. Now these are going to be crossed off for the meantime. I have my point on the graph, 0, 1. X and y. I can simply put that in for x and y into our simplified function. So 1 equals a open bracket 0 minus 1. 0 minus 1 is -1. Therefore 1 equals -a. Therefore a equals -1. So I can simply put a -1 in the location of where a is. -1, and I can finally rewrite it one more time. Y equals -1, x minus 1, x plus 2 over x plus 2. So again, reviewing, if we have a hole, we put the hole on the top and on the bottom. Then we put our x-intercepts on the top. We don't have any vertical asymptotes, so nothing else goes on the bottom. Then we work on our a value. Once we found our a value, we can rewrite the function. Awesome. We learned vertical asymptotes first, but holes are something that we're going to work on first now. When we're looking for the equation, we want to find the hole first. When we're working on the graph, we want to find the holes first and deal with those accordingly. Let's look at a couple more holes. So we have another graph with a hole. So we remembered that we simply put the factor of the hole. So we have a hole when x equals 3. So we simply want to put x minus 3 on the top and the bottom. Now this time we also have a vertical asymptote at x equals -2. So we need to put plus 2 on the bottom at that location. Now we have an x-intercept at -4, so x-intercepts go on the top. I'm going to put x plus 4 on the top. And then again, I'm going to put my a value down. I'm going to choose a point on the graph. As you can see in the notes, we're going to substitute that in for x and y. Solve for a. We get -2. And that is our equation. So the slant asymptotes are a little bit more difficult. Y equals over. So we want to start by putting our vertical asymptote on the denominator, x plus 2. If the vertical asymptote is at x equals -2, x plus 2 goes on the bottom. Now we have an a value on the top, which we'll find eventually. Now we always put the slant off to the right. So y equals a over x plus 2 plus the slant. Now the slant equation is x plus 1, so that goes there. Again, we have a point on the graph, -1, 1, substitute it in for x and y, figure out what a is, find out that a is equal to 1, so we can rewrite it. Y equals 1 over x plus 2 plus the slant x plus 1. That's one form. You could add and subtract fractions to get into one equation, etc. Put it in your graphing calculator, make sure it looks the same. So we've got lots of different methods. Sometimes we want to use one form, sometimes we want to use another, depending on the given information.